Calculate the mean of the scores of grade 9 students in an algebra test. Use the deviation method. These are the scores: 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84. These are the corresponding frequencies: 2, 3, 7, 10, 6, 5, and 2. We need to add 3 columns, 1, 2, 3, and 1 row. Let us write class mark in the third column. Let us represent the class mark by X. 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84 are called class intervals. Each class interval has a lower limit and an upper limit. For example, in the first one, the lower limit is 50 and the upper limit is 54. So these are lower limits. Let us represent the lower limits by LL. And these are the upper limits. Let us represent the upper limits by UL. Notice that the difference between any two successive lower limits is always equal to 5. For example, 55 minus 50 is 5, 60 minus 55 is 5, 70 minus 65 is 5. This difference is called class size, represented by I. So class size is equal to 55 minus 50, and 55 minus 50 is equal to 5. So the class size is equal to 5. 50 to 54 means 50, 51, 52, 53, and 54. The middle number is 52. This middle number is called class mark. So for the first class interval, the class mark is 52. The class mark can also be solved by adding the lower limit to the upper limit and then divide the sum by 2. So for the first class interval, we have 50 plus 54 divided by 2. And 50 plus 54 is equal to 104 divided by 2 is equal to 52. So 55 plus 59 divided by 2 is 57. 60 plus 64 divided by 2 is 62. 65 plus 69 divided by 2 is 67. 70 plus 74 divided by 2 is 72. 75 plus 79 divided by 2 is 77. 80 plus 84 divided by 2 is 82. In the fourth column, let us write D. D means deviation. We need an assumed mean. Let us represent the assumed mean by AM. We can use any of this class mark as our assumed mean. We can use 62, 67, or 72. But it is better to use the one in the middle. So let us say that our assumed mean is 67. To get the deviation, we subtract the class mark from the assumed mean and then divide the difference by the class size. So let us start with 67. 67 minus 67 is 0, divided by 5 is equal to 0. And then 72 minus 67 is 5, divided by 5 is equal to 1. 77 minus 67 is 10, divided by 5 is 2. 82 minus 67 is 15, divided by 5 is equal to 3. 62 minus 67 is negative 5, divided by 5 is negative 1. 57 minus 67 is negative 10, divided by 5 is negative 2. 52 minus 67 is negative 15, divided by 5 is equal to negative 3. Actually, there is no need to do all these computations. Just write 1, 2, 3, and then negative 1, negative 2, negative 3. And then in the last column, write FD, meaning frequency times the deviation. So we multiply 2 by negative 3. 2 times negative 3 is negative 6. 3 times negative 2 is negative 6. 7 times negative 1 is negative 7. 10 times 0 is 0. 6 times 1 is 6. 5 times 2 is 10. 2 times 3 is equal to 6. Then we are going to add this. Negative 6 plus negative 6 plus negative 7 is equal to negative 19. 6 plus 10 plus 6 is equal to 22. Negative 19, positive 22 is equal to 3. So, sigma FD is equal to 3. Then we add the frequencies. 2 plus 3 plus 7 plus 10 plus 6 plus 5 plus 2 is equal to 35. So, sigma F is equal to 35. The formula is mean is equal to assumed mean plus sigma FD over sigma F times I. I is the class size, which is equal to 5. So we just substitute. The assumed mean is 67. So substitute 67 for AM or assumed mean. And then substitute 3 for sigma FD. Substitute 35 for sigma F and 5 for I or class size. So this is now equal to 67 plus 3 over 35 times 5. 3 times 5 divided by 35 is equal to 0.4285. We add this to 67. So 67 plus 0.4285 is equal to 67.4285 or 67.43 to the nearest two decimal places. So the mean is equal to 67.43 to the nearest two decimal places.